Okay, here we go. Lesson 7, the root of the problem. So let's look at relationships between volumes, areas, and scale factors using graphs and situations. Okay, so volume is, well, for cubes, it's, I'll get to that later, but it's basically like the airspace that's taken up. Area, and these are 3D, is going to be 2 dimensions, and then scale factor is like the number we multiply each dimension. Dimensions like length, width, height. Volume is usually, like for a cube, it's length times width times height, 3D. Area is just length times width. And the scale factor is the number we multiply each dimension. So length times the scale factor equals the new length, stuff like that. All right. So a cube whose side lengths measure 1 unit. So what does that mean? Well, you got this cube right here. Okay, side lengths measure 1 unit. It has been dilated, so it's been changed. It's gonna have the same shape, but it's gonna be a different size. That's what dilated means. There's several scale factors to make new cubes. For what scale factor will the volume of the dilated cube be 27 cubic units? Okay. So you need another formula, and this is key, and I'm going to write it like a lot of times on this lesson. But the formula is, it's right here, V times K cubed equals V prime. Now I realize, like, this isn't like, usually, like, this isn't English class, but I'm going to tell you what all these are. V equals the original volume. K equals your scale factor. And V prime is your dilated volume. So that's what you need to know. This formula, volume, original volume, times your scale factor to the 3rd power equals your new volume, or dilated volume. Okay, so with this cube right here, all the sides are the same length, so these are all 1, and a cube's volume is length times width times height, as you know. So 1 times 1 times 1. So your volume of the original cube is just 1. And it's cubic units. So 1 cubic unit for this cube. So that's your V, right? Your original volume. Now, for what scale factor will the volume be 27? So you just rewrite the formula. So V K cubed equals V prime. That's what you want to do first. This is your first step. You know V is 1. You don't know the scale factor yet, but you do know the dilated volume will be 27. So 1 times K cubed will equal 27. 1 times any number is that number, so then you can just say K cubed equals 27, and then you're going to do the cube root of K cubed will equal the cube root of 27. As long as you do it to both sides, you're good. The cube root of K cubed is just simply K, and the cube root of 27 is 3. Now, to find a cube root, you just have to hit some buttons on a calculator. I think that's it, but let me see here. So for this one, you look for the cube root, and it's right here. It's right above the arrow. See that little X and the radical sign? So you're gonna say 3, because we're dealing with a cube root. We're dealing with the third root. Second, so 3 second. Up arrow. You look at there, it changed it to a cube root of 3. And then you just hit the number, 27. And then you hit enter. Or enter, yeah. So that's how you get a cube root. All right. For what scale factor will the volume be 1,000? Same thing, you just use this right here. So V, K cubed equals V prime. Here's V, 1. Don't know what K is yet, but you do know the new dilated volume is 1,000. Meaning K cubed equals 1,000. Just take the cube root of both. You're gonna get K equals, and then let's practice this again. The only thing that's gonna change is the thousands. So we're gonna say 3 second, up arrow, 1,000, enter. K equals 10. All right, here we go. Estimate the scale factor that would be needed to make a cube with the volume of 1,001 cubic units. This is like a number sense problem. So because we know that K equals 10 for the change to 1,000, like, what's a good estimate if it changed to 1,001? Well, you know it's going to be a little bigger than 10. So my estimate, I don't know, let's just say K equals 10.1. That would be a good estimate. Because Mr. Fisher knows K is a tiny bit greater than 10. So K is greater than 10, but not by much. Now, let's really run it. Let's figure out if my estimate was good. I think there's a couple more decimals, but you say 1 times K cubed equals 1,001. And then you're gonna get K equals the cube root of 1,001. So let's practice that again. So I'll clear this out. 3 second, up arrow, 1,001 equals 10.003. So the real answer is K equals 10.003. So 10.1, pretty close. A little bit off, but that's because it's an estimate. So to estimate means to come up with something like pretty close. All right, so here it is again. Estimate, come up with a close scale factor needed to make a cube with a volume of 7 cubic units. This is a number sense problem again. So let's start thinking about our perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed I think is 343, 8 cubed I want to say 512, 9 cubed 81, times 9, is it 729? I think it's 729. 10 cubed is 1,000. All right, so they're asking for what the scale factor would be to make a volume of 7. This is another number sense problem because they're asking you to estimate. So rather than plugging in the formula, let's just come up with an estimate. Well, you know that 2 to the third power equals 8. You know that. So if 2 to the third power equals 8, and we're looking for a volume of 7, remember, 1 times 2 cubed. So if the scale factor was 2, then the new volume would be 8. But we gotta go like 1 times k cubed equals 7. That's where we gotta like kind of come up with an estimate. So I know this k right here is gonna be a little bit less than this 2, just a little bit. So you might say like, well, if we're going to 7, I don't know, maybe k equals 1.9, maybe. And an estimate doesn't have to be exact. An estimate, just come close, right? You have to do that a lot in the real world because sometimes you don't like have a calculator on you. Well, you got a phone now, but sometimes you got to make mental estimates of things. So to estimate, come close. I'm gonna say it's just a little less than 2. We'll call it 1.9. Who cares what the real reason is? Answer is because they asked for an estimate. All right, cool. 7.2, thinking inside the box. So a shipping company makes cube-shaped boxes. Their basic box measures 1 foot per side. They want to know how to scale the basic box to build new boxes of various volumes. All right? If the company wants a box with the volume of 8 cubic feet, by what scale factor do they need to dilate the box? Okay? Their basic box measures 1 foot per side. And they're in cubes. So their basic box is in a cube. This is a shipping company. This is a cube where length equals width, which equals height. So it's 1 foot per side. Now volume is going to equal length times width times height. So for this one, 1 times 1 times 1, volume equals 1. And it's in cubic feet. Okay, so that's V. They now want a volume of 8 cubic feet. To figure out the scale factor, we're just going to use this formula. V times k cubed equals volume prime. We already know V equals 1. So you're going to say 1 times k cubed equals 8. That's going to be the new dilated volume, V prime, right? So k cubed equals 8. Take the cube root of 8, k equals 2. So if they want a volume of 8, the scale factor is 2. Because this formula is the one you need right here. If they want a box with the volume of 10 cubic feet, what scale factor do they need? So again, V times k cubed equals V prime. V is 1, hasn't changed, times k cubed equals 10, the new volume 10. 1 times k cubed is just k cubed equals 10. And this one I don't really know off the top of my head because I don't remember what the cube root of 10 is. If you do, watch out. You've got one of those calculator brains. But this is where you do the buttons again. And those buttons don't change, so if you can remember which buttons to do, you're good. But if you can't remember that, just write it down and go back to it later. So you go 3, then you hit second, hit the up arrow, type in your number, and then hit enter. And you will get, for 10, 2.15, rounded off to the nearest hundredth. Okay? So 1 and 2 are done. If the company decides to create a graph to help analyze the relationship between volume, this is X, and scale factor Y. Okay. Complete the table, rounding values to the nearest hundredth. Hundredth is 2 decimals. Okay, then on graph paper, so this one was y equals the square root of x from lesson 5. We're gonna do down here cube root of x. So we're gonna graph it on down here and compare the two. All right, but first we gotta fill out this table. So remember, it's just v times k cubed equals v prime. V always equals 1. This is also going to be v prime. So let's start here. So 1 k cubed equals 0. So if k cubed equals 0, k equals 0. All right, let's do this one. 1 times k cubed equals 1. So you're gonna get k cubed equals 1. Got a cube root both sides, k equals 1. All right, let's try this one right here. 1 times k cubed equals 5. So you're gonna get k to the third power equals 5. Then you take the cube root of both sides, because the cube root of k cubed is just k. So k is gonna equal the cube root of 5. Now this is where I need a calculator. And we're gonna do the same buttons. The only thing I'm gonna change is instead of 10, I'm gonna use 5. So we're gonna say 3, second, up arrow, 5, enter. And you're gonna get 1.71. All right, so v prime equals 15. So 1, our original volume, times scale factor cubed will equal 15. You will get k to the third power equals 15. Cube both sides, take the cube root of both sides. K will equal the cube root of 15. So for this one, we're gonna go 3, second, up arrow, right. 3, second, up arrow, 15, enter. This one is 2.47. I'm gonna round up. You're gonna start to notice that these are just cube roots of all these numbers if we do all the math. So here's another one. 3, second, up arrow, 20, enter, 2.71. 3, second, up arrow, 27, enter, is 3. All right, so now I gotta graph these. So this was lesson 5. This was comparing area, dilated area. and scale factors. Now for lesson 7, we're going to compare dilated volume and scale factors. Okay, so now the first thing I do to build my graph is I take a look at what's the x and what's the y. So x ranges from 0 to 27. So these are all positive. So you're gonna set up some like axes like this. The top is 27. Y goes from 0 to 3. So this is kind of how my scales are gonna get set up. So now, 27, I probably need 9 spaces. And 3, I'm gonna go with 7 spaces. And I'll show you why. 1, 2, 3, 4, 5, 6, 7. Over here, I need 10. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then just draw your X right here at the end and draw your Y up here. If you want to do like cool fonts, that's not a bad idea. But X represents the volume in cubic feet. So volume in cubic feet. That was given to you in the problem. Y represents your scale factor. All right, now X goes from 0 to 27. So this is, I need, there were a total of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 27 divided by 9 is 3. So each one of these is 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27. That's going to include all of these, because this is X, volume, right? Scale factor, only have to go to 3. So for that, I'm going to do 2 for each. I'm just going to say scale factor 1, scale factor 2, scale factor 3. Now, I just got to plot the points and I'm good. 0 for X, 0 for Y. That's right here. 1 and 1. Since this is 3, 1's over here, so it's like right here. Okay. 5 and 1.71. This is 6, so 5's right here. 1.5 is right there. So 1.71's like right here. 8 and 2. There's 9. 8's like 1/3, and it goes up to 2, right around there. Okay. 10 and 2.15. So there's 9s and 10's like right here. 2.5 is there. 2.25 is there. 2.15 is like right here. Roughly. Okay. 15 and 2.47. So there's 15. Here's 2. There's 2.5. 2.47 is a little bit less, just barely. So why don't we go right there? 20 and 2.71. So there's 21. There's 20. We gotta get to 2.71. There's 2.5. There's 2.75. So a little bit under. There. And then last but not least, 27 and 3. There's 27. 3 is right there. And then they want a smooth curve. So you just go like this. Okay. So this is the graph of y equals the cube root of x. It looks awfully similar in shape to y equals the square root of x. Because it gets steep in the beginning and then it starts to flatten out over time. It's just going to get flatter and flatter and flatter, but it's going to keep barely going up the whole time. Cool. Now, 4, 5, and 6. The graph shows the relationship between the volume of the dilated box, so volume of the dilated box, and the scale factor. Write an equation that describes this relationship. Well, as you know, the volume and the scale factor were all related by the cube root of the dilated volume. So y, the scale factor, equals the cube root of x, the dilated volume. Okay, suppose the company builds a box with volume of 21 cubic feet and then decides to build another with volume of 25 cubic feet. Use your graph to estimate how much the scale factor changes between these two dilated boxes. All right, so all you need to do is go up to 21 and 25 and put like a little note next to them. So 21 is right there, 25 is right there. So you want to also analyze the change in scale factor. So a change in scale factor is like from here to here. So real small change in scale factor. So 2.5 is there. Square root of 21 is going to be, or cube root of 21. That's not very much. I don't know. Let's see. That would be half. This would be 0.25. Looks like about, I don't know, change in scale factor. Maybe 0.125. Represents my estimate of the change in scale factor. We'll call it K, between the two dilated boxes. Number 6. Use your graph to estimate how the scale factor changes between a box with a volume of 1 cubic feet and a volume of 5 cubic feet. Okay, so 5 is right here. So there's 5. That's gonna be like right there. And 1 is right here. So we're talking about this to this. That's the change in the scale factor between 1 and 5. So I'm going to say between 1 to there is 0.5, there to there maybe 0.2. So I'm going to say the change is 0.7. Represents the change of the scale factor between both boxes, both dilated boxes. Now, why did they ask you this question? Well, 25 minus 21 is 4. 5 minus 1 is 4. So they're asking a cool question. What it means is like, even though the volume changed by only 4 in each instance, the scale factor change was much different. The scale factor change was much bigger in the beginning compared to this one. So what you're gonna notice is like, this just gets smaller and smaller for every 4 cubic feet. It'll eventually reach like the limit, which is 0. But anyway, that's calculus, so don't worry about that for now. But that was number 6. All right, satellite scale factors, here we go. Government agency is redesigning a satellite or an object that goes in orbit around the Earth. The surface of the satellite is covered with solar panels that supply the satellite with energy. Okay, so these solar panels are going to give you the energy. All right. The interior of the satellite is filled with scientific instruments. All right. In the current design, the satellite has a surface area of 5.4 square feet and volume of 1.2 cubic feet. Okay. So surface area, 5.4 square feet, volume, 1.2 cubic feet. That's your original surface area and original volume. So let's just write that. Surface area equals 5.4. And it's square feet. So you could put FT to the second. Original volume is 1.2. We're going to put FT to the third. All right. If the agency wants to increase the surface area to 21.6, so the satellite can generate more energy, by what scale factor do they need to dilate the satellite? So we're talking about surface area. So you need a formula for surface area. And this formula is related to the scale factor. I'm going to give it to you. It's the same as area alone. So the surface area changes by this with the same formula that we've used for area. So what that means is surface area times K to the second power will equal surface area prime. Now, in this problem, surface area, the original, like we said, was 5.4. Surface area prime is now 21.6. So you just got to plug these numbers into the formula and then solve for K. Surface area, 5.4, K squared equals 21.6. Divide both by 5.4. You will get K squared equals 26 divided by 5.4. Is it 4? Let's see. 21.6 divided by 5.4 equals 4. Okay, so if K squared equals 4, square root both sides, K equals 2. Easy. If the agency wants to increase the volume to 4.05 cubic feet, by what scale factor do they need to dilate the satellite? Well, we're just going to go back, and if you need to rewind, the last problem had this, but you need the formula for volume related to the scale factor. So this is how much the dilated volume changes based on a scale factor. And that formula is v times k to the third power equals v prime. That's the formula you need. Now v, we already identified, was 1.2. V prime is 4.05. So now you just plug these into this. So v, 1.2 times k cubed equals 4.05. Divide by 1.2. Divide by 1.2. K to the third power equals 4.05 divided by 1.2. 4.05 divided by 1.2. That equals 3.375. So you now have k cubed equals 3.375. Now, to isolate k, you got to take the cube root of both of these numbers, because the cube root of k to the third power is just k, and the cube root of 3.375, remember, there's 5 buttons to hit. Now, I have these memorized. I don't expect you to memorize the buttons yet, but with practice, you might. So 3 second, up arrow, 3.375, enter. Or equals 3 second, up arrow, 3.375, enter. 1.5. That represents the cube root of 3.375. So k is 1.5. So the scale factor they need to dilate the satellite is 1.5. All right, there we go. 38 minutes for a lesson, no big deal. Just keep studying. Watch it again, it's all good. Instead of like messing around on social media, watch these videos. I know they're not as fun, but this is the mental lab. You got to get good. So work. All right, bye.